And then share my screen. And then go to OneNote. So today's topic is Module 8, analysis of variance. It is also called ANOVA test. But before we start, are there any general questions? Anything?
Just wanted to confirm the topics for the quiz next week. So it's is it Module 7 and Module 8, and just confirming that it's
yeah, it is Module 7, Module 8, right?
Okay, so match samples, t-test, and z-test for 2 population proportions, right?
Correct.
Okay, thank you.
You're welcome. And online Module 8 is due this Friday, right?
Yes.
Yeah. Any other questions? All right, so let's start off. So this is today's topic, analysis of variance ANOVA test. So far, as Aaron mentioned, we have hypothesis test about 2 populations, 2 population proportions, 2 population means. But sometimes we do want to compare 3 population means. When you want to compare 3 population means, you use ANOVA test, okay? One example would be, for example, this semester at Ryerson University, Chang School offers 3 different sessions of CQMS 202, 3, okay? If you want to compare the average final mark across those 3 sections, you want to use ANOVA test because you are testing 3 student groups. Okay, so that is the idea is about testing 3 population means. So let's go over some questions. The first question is very basic. In one way, about what is one way? One way means one factor. The example I gave you, we have 3 different sessions of CQMS 202. There is only one factor, section, okay? If you not only compare 3 sections of CQMS 202, you also want to compare, is there a difference between international students and domestic students across 3 sections? If that is the case, you have 2 factors. One factor is section 1, section 2, section 3. The other factor is the status of students. Some students are international students. Some students are domestic students. Okay, so that is the 2-way ANOVA test. It is not our coverage. We only focus on one way, one factor. Okay, in this case, we only focus on section. Okay. So in one way, ANOVA. ANOVA stands for analysis of variance. What is true about null hypothesis? So we want to compare 3 population means. Okay. So in any hypothesis test, you need to write down H0 null hypothesis. Okay. And you need to write down H1. Some textbook also use HA. Okay. So for ANOVA test, H1 is if there are 3 population means, you are saying all the 3 population means are the same. So no difference in population means. Of course, you are given significant level at alpha 0.01 or at alpha 0.05 or at alpha 0.1 level of significance, okay? So that is your H0. Using mathematical expression, if you use mu1 represent population 1 mean, so you have mu1 equal to, and you use mu2 represent population 2 mean. And then you use mu3 represent population 3 mean. So all three population means are the same, okay? So that is H0. And how do you write down H1? What is the opposite of H0?
Not equals.
Yeah, how do I write it? Not equals.
So you would do U1 not equals U2 not equals U3.
That is just part of the picture. But we have a situation mu1 equal to mu2 not equal to mu3. We also have a situation mu1 not equal to mu2 equal to mu3, okay? So if you want to address all the situations, you have to say at least one mu I is different from others. That is H1, okay? At least one mu I could be mu1, mu2, mu3, okay? At least one mu I is different from others. So that is a basic concept about compare three population means using ANOVA test, okay? This one is question 2. You are given four populations. You want to compare the mean, okay? By the way, ANOVA test not only apply to 3, it is 3 or more. Compare 3 population means, 4 population means, 5 population means, 3 or more, okay? So in question 2, you have 4 population, this is 4 samples. Behind those 4 samples, you have 4 populations. You want to compare if those population means are the same or not the same, okay? So you should use ANOVA test, okay, one way. That is, and this question 3, do I have, yeah, question 3. Just move over, yes. Right. An airline wants to select a computer software package for its reservation system. 4 software packages, 1, 2, 3, and 4, are commercially available. The airline will choose the package that bumps as few passengers as possible during a month. An experiment is set up where each package is used to make reservations for 5 randomly selected weeks. A total of 20 weeks was included in the experiment. The number of passengers bumped each week is obtained, which gives rise to accompanying ANOVA output. The question asks you, what is the among group mean squares? Okay, so this question just give you the ANOVA output. So I'm going to explain each and every item in the output. By the way, this table is very, very important. You are going to see this table in the final exam a lot. Many questions, not 1, 2, 3, many questions is about this table. And this is the first time we are encounter this table. Later on in chapter 15 and in simple linear regression and multiple linear regression, we'll see similar table. Okay, so this table is today's focus. Okay. All right, so let's explain. Where do we start? Start with source of variation. Remember, you want to compare. There are 4 groups here because you have 4 software package. So you want to compare 4 population means. Okay. Imagine when you want to compare 4 population means, there are variations. There are 2 types of variation. One type is between groups, means what is the variation between group 1 and 2, group 1 and 3, group 1 and 4, group 2 and 3, etc. Okay, so the variation between groups. The other variation is within groups. Even with one group, the data is different. There are variation. Okay, so first we understand between groups. Between groups has another name, among groups. Among groups, okay. And this SS stand for sum of squares. Okay. I'll type in. Try to find. This SS stands for sum of squares. Okay, the textbook and also the online modules give you detailed step-by-step approach. How do you figure out sum of square? It is basically, you are asked to remember there is a 4 population. Let's say, see here, population sample 1, 2, 3, 4. The data you get is sample, okay? So for each sample, you have some data. Suppose this is sample 1 data, okay? You have sample 1 data, and you have sample 2 data here. The sample size not necessarily the same, okay? Could be different. Sample 1, you have 10 data. Sample 2, 8 data. Sample 3, you have maybe 5 data. Okay, not necessarily sample size is the same. Okay, imagine, okay. When you have 4 groups, can you calculate each group average? Can you? You have 4 groups data. Can you calculate each group's average? Anyone?
Yes.
Excellent, okay. And we call that average, this is a X1 bar, group 1 average. X2 bar, group 2 average. X3 bar, group 3 average. And X4 bar, group 4 average. Those are the group average, okay? Now, consider the whole data is an entity. Can you calculate the overall average for the whole data here?
Yes.
Can you? Okay, so we call that average is X double bar, means total average for all data. Is that clear? So X double bar means total average for all data. X1 bar it is just the average for group 1. X2 bar average for group 2, but X double bar, the average of all this data here, all this data. Okay, so we cleared up with X1 bar, X2 bar, and X double bar. Okay, so what is SSA? Oh, where is my question? Oh, it is here. Maybe I will write here. So this number, did you see 212.4? 200.4. This number called SSA, see this A among groups. This 212.4 is a sum of square among groups. Sum of square among groups. Okay. So how do you calculate sum of square among groups? You use group 1 average X1 bar, okay, minus the total average X double bar, and then you square it. So I will pause for a moment. Anyone has question about this one? Use group 1 average minus total average, square it. Okay, and then times how many number in group 1? Suppose there is N1. N1 represents sample 1 size. Okay, and then repeat yourself for group 2. Okay, so group 2 average is X2 bar, X2 bar minus total average X double bar, square it, and then times group 2 sample size N2 in the front. Okay, and then you repeat yourself for group 3, group 4, and other group, and you add them all. This is SSA, sum of square among groups, and this SSA is given 212.4 from the output. Any questions about how do you calculate SSA?
Can SSA be found through the calculator?
Yes, can be found during the calculator. And I'm going to show you calculator lesson after we explain the related concept. Okay. So this is SSA. Use group average. The difference between group average and the total average. Square it. Add them all. And now, next number you have this 136.4 is SSW, sum of square. W stands for within groups. Okay, sum of square within groups. And how do you get within groups? Okay, so you go to group 1. See, you have data here, group 1. The first number in group 1 minus group 1 average. Okay, square it. Okay, and then add the second number in group 1. The second number in group 1 minus group 1 average, square it. Okay, keep on going until the last number in group 1, the last number in group 1 minus group 1 average, square it. And you repeat yourself for group 2 next time, plus for group 2, and then plus for group 3, etc., etc. And the result is SSW, sum of square within group. Okay. Any question, how do you get SSW? So once you have SSW, the last number 348.8, and we call SST, sum of square for total. It is just SSA plus SSW. Okay. So any questions about SSA, SSW, and SST? All right. So next, let's move on. Degree of freedom. Okay. This number is 3, means the degree of freedom for among groups is 3. And how do you get 3? You use number of group minus 1. We usually use C. Okay, C represent number of group minus 1. And in this question, how many group? We have 4 group. So C equal to 4. 4 minus 1 equal to 3. And that is the degree of freedom between groups. Okay. Any questions? And then you have, this table missed something, but okay. There's another degree of freedom within group. Within group. How do you find out degree of freedom within group? It is total number size n minus number of groups C. Okay. So you count how many samples here, you count how many sample size total, then minus 4. That is the degree of freedom within group n minus C. C represent number of groups, n represent total number size. Okay. And then this MS means mean square. Okay. There are 2 MS. One is MSA. The number should be here, MSA. Okay. How do you find MSA? You use SSA 212.4 divided by 3, you get MSA. Okay, so you use, 212.4 divided by 3, and that result, this result is MSA. Okay, and the next number, it is given 8.525. This number is MSW. Okay, how do you get MSW? You use SSW divided by the number here. The number here is missing. Your task is to find what is the missing number. Okay, so if you have So the relationship is 136.4 divided by degree of freedom for within group divided by this number you don't know, you call it is X. Okay, you call it is X equal to 8.525. So solve for X. So X equal to 136.4 divided by 8.525, you get degree of freedom for within groups. Okay, so let's use Excel to do it. 136.4 divided by 8.525. Maybe I want more decimal place. Format cells. Number. 2 decimal, that's fine. Okay. So those are the two numbers. I'll just copy. Where did I paste the number? I don't know. So I will undo it because when I paste, I messed up. So undo button. Where is undo button? Is this? No, this is not undo button. I want to undo paste.
Maybe it can be where insert is.
Maybe I'll go back. We don't see where is our, maybe we, I just did the paste, those two numbers. Those two numbers are here, but where is my question? My question disappeared. Oh, it is here, right? Yeah, this is the question. No, this is not the question. Where is that table, the output? So I should have a way to undo it. I did, not here, this is go back. I don't see the original question. Where is my question? It should be here, right? Question 4. Question, So what do I do? Let me see.
Maybe go to home.
Go to home.
There should be yeah, right there, undo.
Undo button. Undo again, undo again, undo.
Yeah.
Yes. So at least I got this question. Thank you. I will not paste, but I need those two numbers. So I will write, one is 70.8, is this MSA, okay. So then I go draw, use my pencil. And then I need those two numbers. MSA equal to 70.8. Okay. The other number X equal to 16. Okay. X equal to 16. Okay. So we get number of the degree of freedom for within group is 16. We get MSA is 70.8. Okay, 70.8. 70.8. And then this F is the test statistic. F, yes. MSA divided by MSW. So what is F? I'll write it here. F equal to MSA divided by MSW. So this is F test statistic, okay, MSW. And this number is given, okay. And you compare this test statistic with the critical F value, you can draw a conclusion, okay. And then you given p-value, you compare p-value with alpha. When p-value smaller than alpha, reject H0. When p-value is greater than alpha, do not reject 0. And also you get the F critical value here, see? Okay, you have critical value, you have test statistic. By the way, the distribution of F distribution is skewed to right, something like this. Okay, skewed to right. And if you label critical value, okay, 3.23, this is critical value. Critical value decide rejection region. So this is the rejection region. And now label test statistic. And your test statistic is F. F is 8.3. So 8.3 must be here. See, your test statistic is in the rejection region, so you conclude reject H0. Okay, remember what is H0? H0 said, oh, in this question you have 4 population, okay? You reject this, means your conclusion is based on H1. At least one population mean is different from others. So that is the, this question again, very important. I explained in detail about each and every item in this table, okay? Remember you are comfortable with this table. By the way, there is a general formula here, and you can get this in the online module, as well as textbook. See here, this is the ANOVA output. You have SSA, SSW, we explained. And the degree of freedom for among group is also called between group, is C minus 1. And what is C? C equal to number of groups, that is C. And the degree of freedom for within group is N minus C. What is N? N represents total sample size. Total means add all sample groups together, okay? Total sample size, okay? Total sample size, okay? And then you have this formula. See, I listed the formula here. What is MSA? It is just SSA divided by C minus 1. So this number, SSA divided by C minus 1, you get MSA. Similarly, how do you get MSW? SSW divided by N minus C. Okay, so F, it is just the ratio between MSA and MSW. Okay. And also I give you the hint, how do you get this F test statistic and p-value? Use your calculator. Okay, and our calculator, how do you get? So you just press F5 to get p-value, you use F5 distribution, F4 represent the F distribution, and then F2, F accumulated, you get the p-value. Okay, and to get this test statistic, okay, to get this test statistic, you just need to use, let me see. F3 test, and then F4, F test. So for this one, you just use starting point F3 test, and then F4. Okay. For data, you select a list. Okay. And you can get the result. But in order to create the list, you have to rearrange your data. Okay. So now this is the point I'm going to turn to. Okay. So suppose you want to compare. In one semester, I teach 3 sections of CQMS 202. I have Saturday class, Tuesday class, and Thursday class. If I want to compare the class average across these 3 sections, what do? I randomly selected some students from Saturday class, and I take a look of their final exam mark. Then I randomly selected some students from Tuesday class, and those are the final mark. Lastly, I randomly selected some students for Thursday class. This is the final exam. Okay. So now, if I want to compare, do the hypothesis test, this is original data. And how I'm going to do this? You do this. First, you create 2 lists, not 3 lists. Okay. So list 1, list 2, just 2 lists. Okay. And then in list 1, you count how many students in group 1, 1, 2, 3, 4, 5, 6. You have 6 students from group 1. So you type in 1, 1, 1, 1, 1, type in 6, 1. I'm not sure how many it, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Because there are 6 students in the group 1. And then 1, 2, 3, 4, 5. There are 5 students on Tuesday class. So you type in 2, 5 times. Okay, 1, 2, 3, 4, 5. Okay, so I have 5, 2. And then you count how many from group 3. Here, just 4 students. So group 3, you type in 3, 3, 3. And this is your list 1 and calculator. You type in list 1 here. This is your list 1. Okay. And then list 2, you type in original data as list 2. So original data, you have 86, 78. You have 86, 78. And the last number for group 1 is 45 here. Okay. And then you continue. This number is 58, 87. So continue 58, 87, 58, 87, etc. So last number here is 36. In last 36, you type in here. Okay, so this is your list 2. No matter how many groups, if you want to use the calculator, you only have 2 lists. Okay, and once you have these 2 lists, you go F3, F4. You will get result. Okay, and the result will be, I will show. The result, your calculator result would be in this format here, this table here. Oops. Oh, no. Wait. Your calculator result will give you this table. Your calculator will give you this table. Okay. By the way, the ANOVA test, you see this number here could be your SPSS project. Okay. For example, you want to compare, in the past, I had students doing the project. They want to compare the grocery price across 3 different supermarkets, for example, Food Basics, North Ross, Mantra, for example, okay? So those 3 grocery stores, you want to compare the price, okay? So this is actually a great idea to do your group project using ANOVA test, okay? But when you have the large sample of data, you don't want to enter the data, use this calculator. You want to do it using the SPSS or Excel. And Excel has so if you click data on Excel and then data analysis, you have ANOVA test, single factor, okay? So you click OK button. And I will give you the original data. For illustration purpose, I will see if I can copy this data. If not, that's fine. Select, copy, no. I'll need the mouse button, need the mouse, and then I want to, oops, no, just, no. Okay, Control C, I will make up those numbers, and then I will delete those numbers. I just have a couple of data. Okay, never mind. I can then make up some data, okay? Suppose I will quickly make up some data. And then I will make up some data here. Suppose this is my number, and then make up some, suppose I want to compare, this is the three samples. I want to compare population means. Okay, so what I do, I go to data, data, and then data analysis, ANOVA test, click OK button, input range. So I'm going to select, this is my data, including the label, as you can see. So I check out here, label in first row, okay? And grouped by columns. alpha is here, 0.1 or 0.05 or 0.01 is here. And the output, you can select new worksheet, or you can use the range. Maybe I want to put output just here beside the data. Here is my output. And then you click OK button. Contains input range contains non-numerical data. Maybe because this data I copied, I will maybe manually type in any number here. Remember those data I copied from my OneNote, and then everything I type in, and then I go data analysis, ANOVA. The data range A1C7 correct. That everything is fine. Perfect. See, this is the result. You are going to have similar results from your calculator, okay? For your SPSS group project, if you want, you can also use Excel instead of SPSS, because some students have difficulty accessing SPSS, okay? And then you see, this is your ANOVA table. I analyzed in detail about each number here. Okay, so let's quickly make a decision just based on this data here. Okay, this is p-value. The simple way is the p-value method. Based on this p-value, p-value 0.4, alpha is 0.05, p-value greater than alpha. When p-value greater than alpha, do not reject H0. What is my H0? H0 said mu1 equal to mu2 equal to mu3, means those three population means are not significantly different at 0.05 level of significance. In other words, these three population means are the same or similar. This is p-value method, okay? And if you want to use a test statistic here, okay, F 0.98 and the critical value is 3.88. This test statistic is not in the rejection region. Do not reject H0. Same conclusion as p-value, okay? And make sure you understand each and every number here. The important thing is you also understand the relationship among those numbers. Where is the relationship among those numbers? It is this table here. This table shows the relationship among the numbers. Okay, so that is the ANOVA test to compare 3 or more population means. You can use p-value method, or you can use F-test statistic. Okay, you can use calculator to produce test statistic p-value, and you can use Excel or SPSS to get the result. Okay, any questions? I got one question from student about SPSS project, so I'm going to, I have that ready. So where is my SPSS? Oh, here. Oh, by the way, if somebody, remember you have a 10% online discussion contribution, okay? If somebody asks you, what is SASSW, you can explain them using the discussion board on D2L, you earn the credit. Or you can write a summary of what you learned in this Zoom meeting, okay? And that is part of your contribution. And the same to SPSS group project. Some people may miss this meeting. You can, share what you learned in this meeting. Yeah. All right, this project, you have to create your own data. Okay, you have to create your own data. So collect, analyze data of your choice. Okay. So the topic, you can have, see, this is today's topic, ANOVA test. Next week, we are going to talk about chi-square test, okay? And the last 2 weeks, regression analysis, okay? And you can select any one of these topics. Once you have these topics, and I need to see in your project title page, including the project name, team member's name, and the student number, okay? And the student have one question I get, what do I put in the background? In background, you need to tell me what this data is about. For example, I give you example. Some students want to compare the grocery price, the food price across 3 different stores, food basics, North Ross, Sobi, okay? That is the part of background information, okay? So you need to tell me what this data is about, okay? Because I know nothing about, if you throw me the data here, I know nothing about this data. You have to tell me the story. Oh, those data about the food price once, okay, at food basics, North Ross and Sobi. You have to tell me story. Oh, this data is about student test 1 mark, okay, across 3 different sections. So that is the background, okay? And then establish research objectives. Tell me, what do you want to do? What is your objective? Okay, in this example, maybe I want to compare the student final mark across 3 different sections. Or you may want to compare the food price across different grocery stores. Okay, so that is your objective, okay? And then data collection, tell me, how did you get the data? Did you get the data from Statistics Canada? Or did you go to the website, take the flyer to see the price? Okay, for the project purpose, you are allowed to make up data because the focus is on data analysis. I want to see how do you use what you learned to do data analysis. So you could make up data, okay? But you need to tell me where the data, you know, if you make up data, you just maybe get some real data, okay? And then make up part of the other data. So after you do the data analysis, you draw conclusions and make recommendations or interpretation. Okay. And also the detailed requirement, at least 10 pages, okay? And how do I evaluate your project? Based on this criteria. In the past, I don't have any project get 9, 10. The highest mark I gave to my students is 8. But 8 is excellent, comprehensive of the subject. I didn't see any project has outstanding quality, rare talent, original, okay, incisive mind. I hope I can see 1 or 2 from this group, this class, okay. Most students will get maybe 7, 6, 8, most students in the past, okay, 6, 7, 8. And then you have to do the peer evaluation. This is your peer evaluation criteria. You give your peer 5 excellent, 1 poor, 0 no contribution. Okay, this is the peer evaluation. And lastly, although it is a group project, each and every student must submit the project through the D2L. Okay, so any questions about SPSS group project? Or any other questions? Any questions? All right. In summary, what we did today, we analyzed ANOVA test in detail. We use the F test. We use the p-value method to draw conclusion about 3 or more population means. We also talked about a group project. Hope you enjoyed today's meeting. Thank you so much for your participation. Good night, and I will see you next Saturday.
Thank you so much, Professor. Have a good day.
You're welcome. Bye.